All right, in Chapter 3, Section 6, we're going to be graphing inequalities. So a quadratic inequality in two variables can be written in one of the following forms where a, b, and c are real numbers and a does not equal 0. So we can write, we're still dealing with the same quadratics, so we have an x squared, an x, and then a number, but we could write it with a less than sign. We could write it with a less than or equal to, or we could write it with a greater than sign, or a greater than or equal to. The graph of any such equality consists of all solutions x and y, xy of the inequality. So previously we've graphed linear equations in two variables, and we can use similar procedures to graph the quadratic inequalities in two variables. So these are 3 steps in graphing quadratic inequalities with two variables. So to graph a quadratic inequality in one of the forms above, follow these steps. So step 1, we need to graph the parabola with the equation. So we would graph it as if it were equal to. So what we've seen before. Where do we start when we see a quadratic with this equation? How do we start to graph it? What would we do? We've done this in the past. So it's a quadratic, it has an x squared, so it's going to be a parabola. How do we find points to graph?
You plug in an x.
We could plug in numbers for x. We could factor it, but remember our formula for our axis of symmetry and our vertex? So our axis of symmetry is x is equal to, anybody remember?
Negative b over 2a.
Negative b over 2a. And then that is our x in our vertex. And then we would just plug in negative b over 2a, that number that we found, to find our y in our vertex. So we're doing the same thing to graph. We need to find our axis of symmetry, our vertex, and then we can plug in points to find where exactly our graph is going to go. So once we graph, instead of being a solid line now, we're dealing with inequalities. So we would put a dashed line for an inequality that's just less than or greater than. So our parabola would look like this. Same thing, but with a dashed line. And then we would put a solid line if it was less than or equal to or greater than or equal to. So this is a solid line. I don't know why I'm drawing my parabolas upside down today, but it's fine. Let's put this one right side up. All right, step 2, when graphing our quadratic inequality, we need to test a point xy inside the parabola to determine whether the point is a solution of the inequality. So we're going to pick any point for x and y that falls inside of our parabola. So we would pick a point inside. And see if it satisfies our equation. If it satisfies our equation, we're going to shade our parabola on the inside. If it does not, then we shade the outside. So these are 3 steps when graphing quadratic inequalities. All right, let's take a look at example 1. So I graphed this one for us. I started with my negative b over 2a to find the vertex, and then I plotted the y-intercept too. So I graphed this one for us. So now we need to test points. So we're on to step 2, which is test a point inside. So what is a point inside of our parabola here? Anything in here. Yep, we can do -1, -1. So we're going to pick this point here. So we're going to plug in -1 for x and -1 for y and see if this works for our inequality. So we have -1 is less than -1 squared minus 2 times -1 minus 1. So let's solve our right side. -1 squared is +1, but we have this negative on the outside, so we have a -1. -2 times -1 is +2, and then minus 1. So what do we get on the right side? -1 plus 2 minus 1. 0. So is -1 less than 0? Yes, so this works. So our point inside works. So we are going to shade everything inside of our parabola. If it did not work, then we would shade everything outside the parabola. All right, let's go to the next. Again, in this one, the graph is done for us. So now, okay, so what do we do next? How do we know if we're going to shade inside or outside? What do we have to do? Find a point inside the parabola. Alex says 1, 1. So we have this point here, inside the parabola. So we're going to plug in 1, 1 into our inequality and see if it works. So we plug in 1 for y, and we plug in 1 for x. So 1 squared plus 2 times 1 plus 4. We have a negative on the outside, so this is -1 plus 2 plus 4. What's -1 plus 2 plus 4? 5. Is 1 greater than 5? No. So what do we do when it does not work? We shade the outside area. So we're going to shade everything on the outside. All right, for the next two, we're going to graph them. So we need to graph and then plug in our point and determine if we're shading the inside or outside. So let's start with our graph. My iPad cooperates. There we go. So how do we start to graph this? What do we need to do? The axis of symmetry. So our axis of symmetry is -b over 2a. So what's our b? So we have a -2 on top and then 2 times a. What's our a? 1. So we have -2 over 2, which simplifies to what? -1. So our x in our vertex is -1. How do we find what our y is? Plug it in. So we have -1 squared plus 2 times -1 minus 8. -1 squared is 1. 2 times -1 is -2 minus 8. So what is 1 minus 2 minus 8? -9. So our y in our vertex is -9. So let's go ahead and graph that point. So we're going to go to the left 1 and down 9. Plot our point there. What is our y-intercept here? Where are we going to cross the y-axis? If we plugged in 0 for x, what would we get? -8. So our y-intercept is always this c, which is -8. So we're going to cross the y-axis at -8. So we can put a point there. Now we know our graph is going to be symmetrical. Since we have a point on the right side, we're going to have that same exact point on the left side. And once we have 3 points, we can just draw our parabola through them. Would it be dotted or not?
No.
No, why?
It has a line there.
Right, because it has a greater than or equal to. That equal to means that it is a solid line. What do we need to do next? Pick a point inside of our parabola. So what's a point inside of our parabola? -1, -1? That's what you said, Alex? Okay. So we're going to plug in our x and plug in our y. So we have -1 is greater than or equal to -1 plus -1 squared plus 2 times -1 minus 8. What was your question? Yeah, so technically, we already solved the right side of our equation here. Here. Oh no. So when we were finding the vertex, we solved the right side of our equation when we plugged -1 in. So what are we going to get on the right side of our equation down here? -9. So is -1 greater than or equal to -9? Yes. So are we going to shade the inside or outside? We shade the inside. So since this works, that means we shade the inside. Any questions on this one? All right, number 2. So again, we need to graph this. So we're going to draw our graph. Where do we start to find our graph here? The axis of symmetry, so we need -b/2a. What's our b? -1. So this is a -1 on top. And then what's our a? 2. So we have 1/4. So in our vertex, our x is 1/4. How do we find our y? Plug it in. So we have 2 times 1/4 squared minus 1/4 minus 1. Fractions, yay. So 2 times 1/16 minus 1/4 minus 1. 2 times 1/16 would be 2/16, which simplifies to 1/8 minus 1/4 minus 1. To subtract our fractions, we need all of our denominators to be the same. So I'm going to multiply this second one, top and the bottom, by 2. And then I'm going to multiply the top and the bottom of the 1 to 8. So this is 8/8. And now I just combine the numerators together. So 1 minus 2 minus 8 would be negative 9 over 8. I kind of did that quickly, but everybody sees how I got that? So our y is negative 9 over 8. So let's go ahead and graph this. So we're going to go to the right 1/4, and then we go down 9 over 8, which is just a little bit more than 1. So our point's going to be about there. What is our y-intercept? Negative 1. We're going to cross the y-axis at negative 1. So since our graph is symmetrical and we have that point at negative 1, we're going to have the same point on the right side. So once we have our 3 points, we can just draw our parabola. Is this a solid line or a dashed line parabola? Should it be a dashed line, a dotted line, or a solid line? Solid line because we have a less than or equal to. So now how do we know if we're going to shade the inside or the outside? Sure. Casey said let's try 0, 0. So since 0, 0 is inside of our parabola, let's do it. So we have 0 is less than or equal to 2 times 0 squared minus 0 minus 1. So 0 is less than or equal to negative 1. Does this work? Is this true? No. 0 is bigger than negative 1, so this does not work. If it does not work, do we shade the inside or the outside? The outside. So we're going to shade everything on the outside.